Okay, so we're going to do another electrophilic aromatic substitution. And this time we'll do, how about aniline? Okay. Old friend of ours. All right. All right, I'm going to save time, I'm not going to draw out both possibilities. We know that this is an orthopair director because we just looked it up in the book, or you may know that for some other reason. So I'm going to put it here, put the carbocation here. All right, don't forget there's another hydrogen here. For simplicity's sake, I'm going to leave it like that. So let's go ahead and draw scaffolding for my resonance structures, the parts I don't have to think about. Okay, now we're ready to think. Alright, so these electrons are going to come here. Put the carbocation there next to the nitrogen, which is bothers you because it's next to an electronegative element. Okay, those three. Now we remember this was the big deal. You look at that and you go, really? There's a carbocation right next to an electronegative element? That's what you don't expect, but yet you find that the amino group is one of the greatest activators in orthopair directing, strongly orthopair directing. Why? And it's because of this structure right here. I'm going to say that's arrow 1 and that's arrow 1. I'm going to say that's arrow 2, and this is arrow 2 over here. And what do I have? Arrow 1 is there, so those are still there because it's not, we're going 2, right? Arrow 1 is if they move there. That's staying the same. What happened here? That lone pair of electrons went down there. Oops, wow. Okay, that's the big deal for this. Alright, so the last step is the base comes in, boom, boom. Alright, that's it. If you get a question like this on a quiz or exam, this is probably the most important, or the most, I should say, the most unique to this mechanism is that. So, in orthopair directors, they are orthopair directors because they can mollify the carbocation at carbon, I'm going to call that carbon 1. Carbon 1 is right here. I admit later, it depends on the priority of this electrophile that comes in. It might, if we were not naming that IUPAC fashion, it might not be carbon 1 anymore. But for now, let's call that carbon 1 because they mollify a carbocation at carbon 1. Either through induction, which we saw with toluene. Where's that toluene? I got a little coffee on this since this last video, but that's it right there, right? The carbocation. This is the toluene one from a previous video, and that carbocation, it's got an alkyl group. Alkyl groups are electron donating, so Ortho-pair directors are so because they can mollify carbocation at carbon 1 either through induction, like toluene does here, right? Electrons are getting shoveled into the system through induction, or through resonance, such as aniline. Okay, so then let me leave a question for you. Chlorine, the chloro group, is an OP director. Why? You know the answer is either induction or resonance. You tell me why. And please consider answering this with a mechanism. All right.